In Tokyo, there are intersections where the same thing happens every morning. The red light comes on, the cars stop, and at that moment, blackbirds fly down from the nearby trees, place something on the asphalt in front of the front wheels, and fly back. The green light comes on, the cars start moving. Then the red light again. The birds return and pick up what is left after the wheels. Cracked nuts. The crows of Tokyo discovered this themselves. Nobody taught them. They observed the movement of cars, understood the pattern of the traffic light, and built it into their food-gathering strategy. This is not an exception. This is normal for a crow. Today we are talking about a bird that most of us see every day and barely notice. About a creature that solves problems at the level of a 5-year-old child, remembers human faces for decades, holds funerals for its dead, and deceives its own kind with a sophistication worthy of a detective novel. About the crow, Block 1. What is a crow? Let's start with the confusion most people have. A raven and a crow are not the male and female of the same bird. They are two different species. The raven is larger, completely black, with a characteristic wedge-shaped tail. The crow is smaller. In many species, it is gray-black. In Russian, this confusion is reinforced by the names themselves, and people spend decades thinking they are talking about the same creature. In reality, crows are an entire genus of birds, numbering 43 species. It includes crows, ravens in the strict sense, rooks, jackdaws, magpies, and nutcrackers. They all belong to the corvid family in the order of passerine birds. The smartest birds on the planet are right here. Crows live literally everywhere: the Arctic, deserts, the tropics, mountains, cities, villages. The only condition is that there must be food nearby. And for a crow, food is anything: meat, fish, grain, berries, insects, garbage. The crow is absolutely omnivorous. And this is exactly what made it one of the most successful species on the planet. The wingspan of the hooded crow is about 100 centimeters, and its weight is about 500 grams. In the wild, crows live for about 20 years. In captivity, near humans, with good care, up to 75 years. This is an exceptional number for a bird of this size. Honestly, until recently, I myself thought that a raven was just a large male crow. I learned the truth and felt a little lost. We are all used to this confusion. Block 2. The crow's brain. A bird's brain is structured differently from a mammal's brain. Birds do not have a neocortex, the part of the brain that neuroscientists traditionally considered responsible for higher cognitive functions. For a long time, this was used as an argument in favor of birds being fundamentally less intelligent. Then scientists discovered that corvids have another brain structure, the pallium, which performs the same functions as the neocortex in primates, only it is built differently. Evolution found a different path to the same result. The raven's brain, relative to body size, is one of the largest among birds. In terms of brain-to-body mass ratio, corvids stand alongside dolphins and are second only to humans and some primates. What does this mean in practice? Studies have shown that crows solve logical tasks at the developmental level of a 5-year-old child, sometimes a 7-year-old. They understand cause and effect relationships. They plan for the future. And this is not a metaphor, but a documented experimental fact. In one famous experiment, crows were given a task. To get food, they had to use a tool that was not currently in the cage. The tool was in another compartment, and the bird could take it only now, but use it only later. The crows took the tool in advance, carried it, and waited for the moment when it would be needed. They planned actions for the future instead of reacting to the current situation. Planning for the future is one of the cognitive markers that for a long time was considered an exclusively human ability. Block 3. Tools and tasks. New Caledonian crows are a special species of corvid from the island of New Caledonia in the Pacific Ocean. They became stars of cognitive science in the early 2000s. They do not just use tools. They make them. They take a twig, trim it to the needed length, remove unnecessary offshoots, sometimes bend the end, and use the resulting hook to pull larvae out of cracks in a tree. This is not random behavior. This is a reproducible skill that birds pass on to offspring through learning. It is revealing that if the bird drops the tool while working, it does not abandon it. It climbs down, picks it up, and returns. The tool has value. In laboratory conditions, crows were offered tasks with several levels. To get food, they first had to get a short tool, then use it to get a long tool, and then use that to get the food. 3 consecutive steps, each of which gives no immediate result. New Caledonian crows managed it. This is called meta-tool use. Among animals, it has been recorded in chimpanzees, orangutans, and crows. Almost nowhere else. A separate story is the pitcher experiment, directly recreating Aesop's fable about the crow and the pitcher of water. The birds were given a pitcher with water, in which a piece of food was floating. Too deep to reach with the beak, stones lay nearby. The crows dropped stones into the pitcher, raised the water level, and got the food. They understood the principle of liquid displacement. Moreover, they chose heavy stones over light ones and dropped them specifically into the water, not into a neighboring container with sand. They understood what worked. This moment with the pitcher personally amazed me the most. It is Aesop's fable. We read it to children like a fairy tale, and the crow actually does it in a laboratory. On the first try. First question for you. Have you ever seen a crow solve some non-trivial task, fight with a dog, open a bag, or use something as a tool? Write in the comments. Block 4. Memory and faces. At the University of Washington, a study was conducted that changed the understanding of crows. Scientists put on masks and, wearing those masks, caught crows on campus. A simple operation. Caught them, marked them with a ring, released them. Then they walked around the same campus, sometimes in the masks that had been used during capture, sometimes in other masks, sometimes without masks, and observed. The crows that had been caught in specific masks reacted aggressively specifically to those masks. Even several years later, they dive-bombed, screamed, and gathered a flock. But other masks caused no reaction. They remembered a specific face as a threat. But the most astonishing thing was that birds that had never been caught learned this too. Young crows born after the experiment reacted to the dangerous masks the same way as the adults. Information about the threat was passed through generations. This is not instinct, it is cultural transmission of information, social learning. Something we are used to considering an exclusively human phenomenon. Crows remember people who harmed them, keep that address in memory, and pass it on to their children. The reverse side. Crows also remember people who fed them. In Japan, Canada, and Russia, cases have been recorded where crows brought gifts to people who regularly fed them. Buttons, coins, shiny stones, pieces of glass. This is not an accident. This is behavior that repeats regularly enough to be studied systematically. Block 5. Deception, caches, and conspiracy. Crows make food stores. Many people know this. Many other animals can do this too. But crows went much further in this matter. When one crow hides food, it watches whether others are nearby. If they are, it makes a fake cache. It pretends to bury the food, while actually leaving nothing there. Then it flies to another place and hides the food there. If observers follow it, it makes another fake cache, and rehides the food if it feels it has been exposed. This is called tactical deception. It requires several complex cognitive operations at once. Understanding that another bird sees what you see, predicting its behavior, simulating a false action, and changing strategy depending on the observer's reaction. Tactical deception has been recorded in chimpanzees, in children older than 4, and in corvids. An important detail: crows that steal other birds' caches themselves hide their own caches more conspiratorially than crows with less experience in theft. They know how others search because they search that way themselves, and they use that knowledge to hide their own food better. Another documented fact: if a crow suspects that it was seen while making a cache, it returns later and rehides the food in another place, but only if there was a real observer. If the crow hid food alone, it does not rehide it. It tracks who saw what. You know, this really got to me. The crow does not simply lie. It models in its head what another crow sees. This is called theory of mind. It was believed that only humans and primates had it. Turns out, no. Block 6. Social life. Crows form pairs for life. Monogamy in them is not an exception and not an accident. It is a stable strategy because raising offspring requires 2 parents. One hunts, the other guards the nest. Young crows, before finding a partner, live in large, noisy flocks. These are a kind of youth companies. The birds communicate, play, and learn social norms. After finding a partner, the pair leaves and no longer returns to the flock. If the partner dies, the second crow may remain alone for a long time. Observers have recorded cases of widowhood stretching for years. When a bird dies in a flock, something happens that scientists call crow funerals. Several birds gather around the body, scream for about 15 minutes, then fall silent and sit motionless. Then they fly away. Why is this? Scientists suggest that it is not grief in the human sense, but information gathering. The gathered crows are trying to understand what killed their relative. The place, the smell, the presence of a predator nearby. This is learning from someone else's death, a social mechanism that increases the survival of the whole group. But it looks exactly like a funeral. Crows protect their own. If a bird is injured or sick, the flock feeds it, cares for it, and does not abandon it. Cases have been recorded where healthy crows fed injured relatives for weeks until full recovery. Second question for you. Have you ever noticed a crow watching you? Or seen a crow tease a dog, a cat, or another person? Tell us. Block 7. Play. Crows truly play. They slide down snowy roofs and icy hills, not out of necessity, but just because. They climb up, slide down, climb up again, slide down again. This is play for the sake of play. They drop objects from a height and catch or throw them to a partner, who catches them and throws them back. This is a direct analog of playing ball. They tease other animals by swooping at a dog, pulling its tail, and jumping away. Repeating, this is not aggression. They have enough experience to know that this specific dog will not catch them. This is exactly play, tickling the nerves. In the forest, crows sometimes fly beside a fox or an otter, tease it, provoke it, dodge it. Researchers have observed this many times. Play in animals is a sign of a developed brain. It requires an excess of cognitive resources, which are usually lacking in ordinary life. Only those who have something beyond what is strictly necessary for survival can play. Among birds, only corvids and parrots play like this. No one else. Block 8. Language and communication. To the human ear, a crow says, caw. This is about as informative as saying that humans make the sound ah. Crows have a complex system of vocal communication. Different variations of calls carry different information. An alarm signal, a food signal, a partner call, a warning about a specific type of predator. Crows distinguish a predator in the sky from a predator on the ground and call differently. Other animals in the area understand this. Squirrels and small birds react to the crow's air raid alarm correctly. They hide under cover. Moreover, dialects have been found in different crow flocks. A group of birds from one area has slightly different variants of signals than a group from a neighboring area. This is cultural transmission of language, not instinct, but a learned system that differs slightly from flock to flock. In Austria, researchers discovered that ravens use beak gestures, point to objects, and show a partner something interesting. Before that, the pointing gesture was considered an exclusively human and primate feature. They did not expect to find it in birds. Captive crows can learn human words and do it better than many parrots. At the same time, they clearly connect words with situations. This is not just sound reproduction, it is the use of a word in context. Block 9. Crows and humans. Crows occupy a special place in human history. Practically every people who lived near these birds has myths, beliefs, and symbolism connected with the crow or raven. In Norse mythology, two ravens, Hugin and Munin, thought and memory, sit on Odin's shoulders and fly around the world every day, reporting to the god what is happening. This is not a random image. People observed crows and ravens for thousands of years and saw them as scouts, watchers, creatures that know more than it seems. Ravens still live in the Tower of London. According to legend, if they leave the tower, the British crown will fall. The birds' wings are clipped so they do not fly away. They are fed meat, eggs, and biscuits. Each raven has a name and a personal card with its date of birth. This is a state tradition that is several centuries old. Celtic war goddesses, the Morrigan and Bab, took the form of a crow on battlefields. The crow circles above the battle. The crow feeds on the dead. This is real bird behavior, which people saw and gave supernatural meaning. In China, 3 crows in the solar disk are a symbol of the sun. In Japan, the 3-legged crow Yatagarasu is a messenger of the gods, showing the way. Almost everywhere, the crow is a boundary between worlds. A bird that sees what is hidden, knows what is unknown to others. Perhaps because this is not so far from the truth. Edition 1. The Crow as a Scientist. There is one experiment that became textbook material in cognitive science. It is called Eiga's task, after the New Caledonian crow that participated in the study. Iga was given a tube with food at the bottom. The food could be retrieved only with a hook. There was no hook. There was a straight piece of wire. Iga looked at the wire for a few seconds, then held one end with her foot and bent the other end into a hook with her beak. She took the resulting tool and got the food. She had never seen hooks before. Nobody taught her to bend wire. She solved the task independently, in real time, from scratch. When the video recording of this experiment was published in the journal Science in 2002, a real discussion began in the scientific community. What exactly is happening inside the bird's head at that moment? Is it insight? A sudden understanding of the solution? Or something else? Repeated experiments with other crows showed that this is reproducible. Most individuals cope with similar tasks. The speed of solving differs, but the solution is found. For comparison, most chimpanzees do not cope with such a task at all. Addition 2. Crows in time. Crows understand what the future is. This sounds banal, but in reality, it is an exceptional cognitive ability. Most animals live in the present. They react to stimuli here and now. Planning, meaning performing an action today for the sake of a result tomorrow, requires the ability to mentally imagine a situation that does not yet exist. Scientists from Lund University in Sweden tested this on ravens. The birds were given access to a trading window through which they could exchange a token for food. Then the window was closed for 15 hours. Before closing, the birds were offered either food right now or a token that would be useful only after 15 hours, when the window opened again. The crows chose the token. They postponed immediate reward for future benefit. They planned 15 hours ahead, through sleep, through a long wait. This is called delayed gratification. In children, this ability forms at about 4 years old. In most animals, it does not form at all. Addition 3. Crows in the city. Urban crows are a separate story. These are not just birds that got used to living near people. These are birds that actively use the city as a habitat and adapt their behavior to specific conditions. Tokyo crows and traffic lights have already been mentioned, but this is not the only example. In Russian cities, crows have learned to open garbage bins. Not just overturn them, but specifically open lids with latches. They observed people doing it and reproduced the movement. Crows in Moscow have memorized the schedule of garbage trucks. They appear near garbage bins shortly before the truck arrives, knowing that at the moment of loading, the contents will become accessible. This is not coincidence. This is knowledge of a schedule. In Canada, crows systematically steal bait from fishermen, pulling the fishing line out of the ice hole with their foot, step by step, until the hook with the bait ends up on the ice. They invented this independently by observing the fishing process. Urban crows are larger and smarter than their forest relatives. This is documented. The city is an environment where the brain literally receives more stimuli, more tasks, more opportunities for learning. Crows raised in the city show higher results in cognitive tests. They are evolving together with us, literally. I now look differently at the crow that sits in my yard every morning on the same lamppost. I wonder what it has already managed to understand about me. Addition 4. How do you befriend a crow? Many people have noticed. If you once offended a crow, it remembered you and will remind you of it at every meeting. By screaming, dive bombing, sometimes with a precise hit from above. But the reverse is also true. If you regularly feed crows in one place, they remember you and start waiting. Some begin to bring gifts. Zoologist John Marsloff from the University of Washington described how his daughter regularly fed crows. And over time, the birds began leaving objects for her right by the plate of food. A button, a piece of mirror, a bent paperclip. This is documented testimony. Crows can show something similar to gratitude. If you want to befriend a crow, feed it regularly, in one place at one time. Do not make sudden movements. Gradually, it will begin to come closer, then take food from your hands. It takes time, but it works. People keep crows as pets and describe them as exceptionally intelligent, affectionate, sometimes jealous creatures. A captive crow can learn several dozen words. It uses them in context. It does not simply reproduce a sound, but says, "hello" when someone enters, and "bye" when someone leaves. This is not training. This is understanding. Addition 5. Crows and death. A topic that scientists study carefully because it easily slips into anthropomorphism. But there is data, and it is interesting. Researchers from the University of California, Davis observed the behavior of American crows near dead birds. They wanted to test the funeral hypothesis. Is this really a ritual or simply a reaction to an unusual object? Here is what turned out. Crows sit near the body of a dead bird. They scream, then fall silent, then fly away, and after that, avoid the place where the body lay for several days. This is not just curiosity, it is avoidance of a dangerous place, learning through observing someone else's death. But there is a nuance. Near a dead crow, they screamed much longer and louder than near a dead bird of another species. This means they distinguish their own from others, and the death of one of their own causes a stronger reaction. Calling this grief means projecting human emotions onto a bird, but calling it simply a reflex means ignoring the data. The truth is most likely somewhere in between. Crows live a long time. They know their relatives for years. They form stable social bonds. When someone from this network disappears, something happens. We do not know exactly how this is experienced from the inside, but something definitely happened. Addition 6. The Crow and Mirrors. The mirror self-recognition test is one of the standard tools of cognitive science. The idea is simple. A mark is placed on an animal, which it cannot see without a mirror, and researchers watch whether it tries to remove the mark while looking at the reflection. If yes, it means it understands that it sees itself in the mirror. Chimpanzees, orangutans, gorillas, dolphins, elephants, killer whales, and corvids have passed this test. Magpies became the first birds to pass the mirror self-recognition test in 2008. Since then, similar results have also been obtained with crows. What does this mean? It means that the bird has an image of itself. The concept of I is not an abstraction. It is a specific neural construction that allows one to distinguish oneself from the surroundings. The list of creatures that have this: humans, great apes, dolphins, elephants, killer whales, corvids. That is all. Next time you look at a crow by a garbage bin, remember, this creature knows that it exists. Closing. Every morning you go outside and almost certainly see a crow. It sits on a lamppost, walks along the sidewalk, digs through a garbage bag. An ordinary gray bird. But in reality, a creature that recognizes your face, remembers it for years, evaluates you as a threat or as a potential ally, passes this information to its chicks, plans actions several steps ahead, can deceive, make tools, and negotiate. It observes you and perhaps draws conclusions about you. Third question. Has your attitude toward the crow changed after this video, or is it still just a noisy bird in the yard? Write in the comments. It is always interesting to read.